Hi everyone, welcome back. In this video, we learn about the built-in math module in Python. This module gives you instant access to many mathematical functions like square roots, powers, rounding, and more. The math module is a built-in Python module that contains a collection of math-related functions and constants. Think of it like a toolbox that gives you instant access to advanced operations like square roots, factorials, trigonometry, logarithms, and more. To use the math module, we need to import it first. Let's open PyCharm, create a new folder and name it as math. Right-click on math folder, choose new then Python file, give it a name math_operations. Now at the top of the file, let's import the math module. Let's type import math. This line gives us access to many mathematical operations such as square root, power, rounding, and more. Let's now calculate the square root of a number. We'll use the square root function from the math module. We'll type a print statement like this, print within parentheses, then inside quotes, say square root of 16 colon followed by a comma, and then we call math.square-root function and pass 16 as the argument. This will calculate the square root of 16, which is 4.0. Python always returns this result as a floating point number. Let's now run the program and see what happens. A square root of 16, 4.0. That's correct, because 4 multiplied by 4 equals 16. So the square root is 4. You can try changing the value to 25 or even 100 and test it again. Now let's raise a number to a power. We'll use the power function math.pow. Let's say we want to calculate 2 raised to the power of 5. In our print statement we say print within parentheses inside quotes 2 raised to the power of 5 colon comma math.pow and pass 2 and 5 as arguments. This will compute 2 to the power 5, which is 32.0. Let's run the code now. 2 raised to the power of 5, 32.0. Excellent. You can test other combinations like 3 raised to 4 or 5 raised to 3. Let's now find the absolute value of a negative number. We'll use the function math.fabs. In our print statement we write print within parentheses, then in quotes absolute value of negative 9 colon comma call math.fabs and pass minus 9. This will return 9.0 because absolute value always removes the negative sign. Let's run it and check. Absolute value of negative 9, 9.0. Perfect. You can also try with negative floating values like minus 15.6. Now let's round a number down to the nearest integer. We use the floor function math.floor. Let's say the number is 7.9. We type print then in quotes floor of 7.9 colon comma call math.floor and pass 7.9. This will round it down to 7. Exactly right. Even if the number was 7.1, floor would still round it down to 7. Now let's do the opposite. Round a number up using ceil. Let's try ceiling of 7.1. We type print quotes ceil of 7.1 colon comma math.ceil pass 7.1. This will round it up to 8. Ceil of 7.1 8. Try changing the value to 4.3. Ceil would round it up to 5. Let's now calculate the factorial of a number. We'll use the factorial function from the math module. Let's find the factorial of 5. We write print within parentheses, then inside quotes, factorial of 5 colon, comma, then we call math.factorial and pass 5 as the argument. This will calculate 5 times, 4 times, 3 times, 2 times 1, which equals 120. Let's now run the code and check the result. Factorial of 5, 120. Awesome. You can also try values like 6 or 7. Just remember, factorial only works for non-negative integers. Let's now look at two important mathematical constants. The first is pi, math.pi. To print the value of pi, we say print within parentheses, quotes, value of pi colon, comma, math.pi. This will give you 3.14159 and so on. Let's now run this. Value of pi 3.1415925 and so on. Perfect. Now the second constant is Euler's number, written as math.e dot. This is used in exponential and logarithmic functions. To print the value of e, we say print within parentheses quotes Euler's number colon, comma, math.e. Euler's number 2.71828 and so on. These constants are built into the math module, so you can use them in your calculations anytime. Let's now convert an angle from radians to degrees. Let's say we want to convert pi radians, that's math.pi, to degrees. We write print quotes pi radians in degrees colon, comma, then call math.degrees and pass math.pi. This will convert pi radians to 180 degrees. Let's run the code now. Pi radians in degrees 180.0. Excellent. You can also try math.pi divided by 2, which will give you 90 degrees. Now let's go the other way. Convert degrees to radians. Let's convert 90 degrees to radians. We type print quotes 90 degrees in radians colon, comma, call math.radians and pass 90. This will return the value in radians, about 1.57. Output on the console, 90 degrees in radians, 1.57. Great. These functions are useful when working with trigonometry or graphics. Trigonometric functions, math.sin, math.acos, math.tan. Let's now calculate sine, cosine and tangent of angles. But remember, we pass angles in radians, not degrees. So let's first calculate the sine of pi divided by 2. We type print quotes sine of pi divided by 2 colon, comma, math.sin, and inside that math.pi divided by 2. This will return 1.0, the sine of 90 degrees. Sine of pi divided by 2, 1.0. Next, let's calculate the cosine of 0 radians. Type print quotes cosine of 0 colon, comma, math.cos and pass 0. Cosine of 0, 1.0. Finally, let's do tangent of 0, just like before. Math.tan, pass 0. Tangent of 0, 0.0. These functions work for any angle in radians. Let's now calculate the natural logarithm of a number. We'll use the log function from the math module. This function gives the logarithm of a number to the base e, where e is approximately 2.718. Let's calculate the natural log of 10. We type print within parentheses inside quotes natural log of 10 colon, comma, math.log and pass 10 as the argument. This gives us the power to which e must be raised to get 10, which is around 2.3. Let's run the program and output on the console. Natural log of 10, 2.302 and so on. You can try other values too, like 20 or 100. Now let's calculate the base 10 logarithm. We'll use math.log 10. Let's find the log base 10 of 1000. Type print within parentheses quotes log base 10 of 1000 colon, comma, math.log 10 and pass 1000. This will return 3 because 10 to the power of 3 equals 1000. Let's run the program and output on the console. Log base 10 of 1000, 3.0. Perfect. Use log when you want base e and use log 10 when you want base 10. Let's now find the greatest common divisor between two numbers. We'll use math.gcd. Let's find the GCD of 54 and 24. We type print quotes GCD of 54 and 24 colon, comma, math.gcd and pass both numbers. This will return 6 because 6 is the largest number that divides both. Let's run the program and output on the console. GCD of 54 and 24, 6. You can use this to simplify fractions or reduce ratios. Now let's calculate the square root but return only the integer part. We use math.I square root. Let's try it with the number 20. We type print quotes integer square root of 20 colon, comma, math.I square root and pass 20. This will return 4 because 4 times 4 is 16 and 5 times 5 is 25, which is too much. Let's run the program and output on the console. Integer square root of 20. This is very useful when you want a square root without decimal values. These are the useful math module functions. Thanks for watching and I will see you in the next lecture.